Afternoon, everyone. My name is Ray Glant. We are a specialty contractor. We actually specialize in 24-story apartment buildings that start in the letter A, or malls that start with the letter A in Newfoundland, where we do work as well. No, I find the thing. Yeah, here we go. I am a hashtag BIM lever, right? I haven't seen a trend on Twitter yet, but I've been invested in this process for about 4 years now. I started with Atlantica then. I formerly was in the sim industry that we heard about earlier today, doing shipbuilding. So when Tom called me and asked me to come on board, I said, well, this should be easy, right? It's probably just like a ship. Everyone understands it, everyone's invested, the trades will want to do it the way that we've built ships for years. And I quickly realized that was not the case in the construction industry. And we came to this same meeting, I think it was 3 years ago, and there was 30, you mentioned it earlier, 30 people in the room, much more than 30 today. So it's coming to construction, but it's been a while coming, I think. So for the presentation today, I did up an agenda because I have to for me so that I can try to stick to those times. I've never done this presentation before, so if I do stick to those times, I'll be happy with myself. In construction, we always start with a safety moment. So I will do that first, a little bit about us as Atlantica, a little opportunity to showcase some of what we do, talk about our processes and how they differ in various types of buildings. Then I'll get into the benefits of BIM from our perspective, try to give you some examples on fabrication. That's probably the biggest benefit to the trade contractor, is the ability to prefabricate our products prior to or opposed to doing it on the actual construction site. Then I'll do a quick two quick videos. One's on the sequencing of a mechanical room at the Nova Center, which we're doing with Ellis Dawn. And the other one is then a tour through that mechanical room to give you an understanding of the scope from an actual person's perspective and the size of that room relative to an individual, similar to the Navisworks realism thing that Crombie did. Then we'll get into the challenges with the current practices that we see within the industry within Atlantic Canada. Then we'll get into some questions if there is any. So safety, like I said, we're a trade contractor. We always start every meeting with safety, even the ones in hotels, especially when you just want an award for safety, because it gives me the opportunity to brag. I'm not going to tell you don't spill your coffee or don't stab yourself with your pen or anything silly like that, but I'm going to say that we just won the Safest Company of the Year for the Nova Scotia Construction Safety Association for companies with payroll over $1 million. So little opportunity to brag. We just actually got it, thank you. We just got it last week in another hotel, so there was my chance. So, Atlantica Mechanical. We are called Atlantica Mechanical. It's not the only thing we do, though. We do quite a bit, actually. Contracting is our primary value stream. Fabrication is something we offer, whether it's prefabricating for our own building systems or whether we're fabricating for someone else. We've built everything from fireplaces to countertops to laboratory equipment and everything in between, including all the stuff you'd see above the ceiling tiles. We also do services, full FM, and you'll see our process starts with BIM right after the design intent is complete, and we'll roll it right into actual FM utilizing our BIM models. We also do design coordination. We take it from what I like to call the design intent process to a constructible model. And there are some differences. Some would argue there's not. I would definitely argue there is. We also do building controls. We also do electrical. We do quite a few other things. We're one of Atlantic Canada's premier mechanical contractors. We have over 300 employees, and that fluctuates, I guess, based on our projects and the number of projects that we currently have underway. We're a member of the Cahill group of companies out of Newfoundland is their head office. We do hundreds of projects a year, hundreds of miles of pipe, millions of pounds of metal, mostly sheet metal. We also do, here's the other things we do, I guess, fire suppression controls, plumbing, heating, AC, service, fabrication, electrical design, BIM coordination. Our process, BIM process varies depending on the type of work, as I mentioned during the agenda. Design build, design assist, bid spec, all those various forms determine when we get involved in the process of the construction, right? Design build, a lot easier. We can have influence to the Revit models, the 2D, depending on the type of the way that the engineering group and architects decide to produce the product. Hopefully, you know, more meetings like this, it will all be in some type of 3D format. When we're bidding a spec, we're obviously later in the project. A lot of the design elements have hopefully been clarified or not, which leads to additional time. Renovations, it's a tricky one for us. Our process is very BIM driven. We start it, with our design group. I welcome everyone to talk to me after, and I'll take you over to our facility and put you through a tour. I usually do 1 or 2 a week, showing how our process flows from the 3D model into fabrication out to the construction site. Renovations are a tricky one. 3D scanning obviously helps. There's a lot of post-process, there's a lot of post-scanning processing that has to occur after the 3D scan, that if not done by the consultant or not carried in the budget for the renovation, we have to complete it ourselves, which makes it challenging. It varies on which consultants are involved. As you know, some consultants in here are here to learn what others are doing in the BIM space. Others are already fully BIM enabled. We've worked with consultants from all over the world. I'll probably talk about some projects later we've done in the southern US that are drastically different than some of the ones we've done around here. And again, the stage of construction when we get involved, which I mentioned earlier, and the technology used, which are obviously important. So the basic premise of it in the extraordinarily high level view is, the design. So if it's bid spec, we're not very involved in that. We get into the coordination just after that. If it's design assist, we're obviously play a very large role in that. Specification can have a lot to do with how much BIM is going to be done on the job, whether we are the lead or there's a separate BIM group that does it, which I'll get into in a slide or two. Coordination, obviously I said design intent versus constructability. It also gives us the ability to use the BIM model, as people were mentioning, Navisworks or Revit, to create a construction schedule, or the fourth dimension, I guess. RFIs, coordination, a little anecdote I like to tell people. For a similar size job from a square footage perspective with the same consultant, since we've started BIM, we started about 8 years ago, I think. Tom, am I right in that? It was around 8 years ago. And we've obviously drastically changed the way we've done it since then, because the industry's evolved, we have evolved. RFIs, there was a job's 100,000 square feet building. We used to produce anywhere from 100 to 400 RFIs, depending on the quality of the job. With our new integrated process where we're acting as the lead coordinator and we bring all the parties together, owners, which I'll get into in a minute, owners, architects, engineers, all of the sub-trades, we've reduced those RFIs to around 10 to 15% of our original RFIs on a job, because we can identify so many of them in a design coordination meeting with a simple conversation. Hey, Joe, can we move this? Yeah, why don't you move that? It makes sense that you can't do anything else. You've shown me in 3D visualization that I am stuck with lowering that ceiling or moving that bulkhead or removing that door. So we've had a drastic impact on the number of RFIs, and it's from that meeting process that you see just below them. Fabrication, once we produce a BIM model, that BIM model gives us the ability to produce material lists. I think Ellis Dawn mentioned earlier that you go to a sheet metal shop, once they do their BIM stuff, and it was one of the sheet metal was where we started as well. In fact, it was the only thing we coordinated, which made it challenging because we built it and got to site and everyone else was already there, so we'd have to do some rework. But it gives us the ability to pre-manufacture our products using a lot of computer-assisted help with that, which I'll show you some small examples of later. Heating and fire suppression pipe, we've been manufacturing that in a shop layout for a long time, but this has given us a greater deal of accuracy in that manufacturing, so we don't have as much rework. In fact, there's some jobs we don't even set up a pipe threader, right? So as a trade contractor doing a lot of pipe, that's, to me, a big deal. Plumbing, we pre-manufacture plumbing. You'll see some examples of that. Then in the construction side, there's construction, installation, and commissioning, all of which we like to play a large part in. And then on facilities management, service maintenance, and then planned versus corrective maintenance. And we can actually take our BIM model and correlate it right to a planned facility management and serviceability. We can tie it into a separate sets of software that will allow the facility manager to actually track, identify with alarms what equipment they have that requires additional maintenance or upcoming maintenance, or if they need to repair it, they have the option to find the shop drawings right in our 3D model. Software we use, Revit, obviously, it comes up a lot. We use a fabrication suite of software, which probably a lot of the people in the room aren't used to hearing about. It's an Autodesk product that it can tie into Revit. There's now Revit modules that exist within Fabrication. You can load parts libraries that are from Fabrication. And what it does is, when you draw in Revit, as I'm sure most of you, if you haven't drawn in it, you've seen examples of it, you draw a run of ductwork in Revit. If you're not using a fabrication module, it draws straight runs of ductwork, right? 50 feet, no joints. Well, that's not how we build ductwork. Ductwork is typically built in 48 or 60-inch lengths, has a TDC flange or an S and drive connection. Those additional connections take additional space, they create additional weight. So we draw in a suite that actually has true to form fabricatable parts. When we draw a piping system, I wish we had an exposed ceiling in here because then I could point and stuff, but when we draw a piping system, we actually load a Victaulic coupling or a roustabout coupling that is the exact spatial dimensions of that exact coupling that we're using. It even specifies the catalog number of that coupling, you know, a 107 versus a 77, which is one that clips together versus one that has to be taken apart and put together. One that has flexibility in its joints for, you know, the piping that comes after pumps. We obviously still use a lot of AutoCAD. We still get a lot of things in AutoCAD. I think I have it later in the slide, but I want to say it in case I forget. The gentleman who asked the thing about detailing, we still see, here's your Revit model, here's your Revit model, here's your 2D details, right? Here's your P&ID for your piping system that's not actually in your Revit model. So they'll change something in the Revit model for spatial coordination and the P&ID won't reflect it. So we do still see that a lot. Navisworks, obviously, that's one of our bread and butters. I have it on my phone. I have it on all of our tablets, on our computers. We often create our own key plan and layering hierarchy, which is different from what a lot of you guys would probably expect, because we have a tendency to separate buildings based on systems versus what fits on a page or a perfect quadrant, things of that nature. So when we're the lead coordinator, we basically act, you know, a couple examples, Halifax Central Library, Nova Center. We basically act as in this region because we were a lot further ahead than a lot of the other people who were later adopters. We act as lead coordinator. We bring everyone together. We bring them to our facility. We have the smart board technologies. We review the 3D models with them, the engineers, architects. In fact, I think my next slide is showing the players. Other projects, there's been third-party coordinators. It's not the general contractor. It's none of the players that were involved. It's literally a company, a lot of them in the U.S., that specialize specifically in BIM coordination, and that is their primary role. They just act as the kind of central point or the hub to gather all that information together. Great example of one of those was the Bermuda Hospital that we did some work on. And the general contractor, I can't recall who it was, but they didn't actually do the coordination. It was a third party. So here it is, just to give you an understanding of some of the people we have to deal with on a daily basis when we are the lead coordinator. You've got your GC, your controls, your miscellaneous metals, your surveyors, your concrete formers, drywall, structural, architectural, electrical, the owner's representative, fire suppression, design, and then there's us, which does all the other things I mentioned earlier. So you get all those players working in one space, it gets challenging to do construction. So things like sequencing, which I'll talk about later, play a very important role. Next slide is just shifting us out to the outside, which, again, I mentioned we did before. So, right to the benefits. Pre-construction benefits. I'm breaking this up into pre-construction and during construction. So before the construction, it gives us some understanding of our schedule development and control. RFIs generate it much earlier in the process, and which is less costly and more timely for the actual implementation or construction of the building. And potential to make architectural and structural changes to minimize site impacts. We still do the odd job where they don't allow us enough time at the front end of a job to actually do full BIM coordination. And when that happens, you know, we try to sell them at the start. Really like you to give us an extra month because we'll make it up to you in the schedule by prefabricating it and crashing your construction schedule. No, got to have people on site, so we start without BIM, right? So we don't have a fully coordinated space. We get into the building, it gets more costly, it creates problems for the construction manager, the owner, et cetera, because the costs that we could have identified on a screen, we're now identifying when we have our ductwork up and our sprinkler up, and the electrician or another contractor comes in and says, oh, I get you to move that because I need to put this there, I need a junction box, a pull box, whatever it might be. We're tearing it out, putting it down. It's not our fault, I'm sorry. So it's obviously an additional cost. Design changes due to coordination. It's one a lot of people don't talk about, but we've seen it in a few jobs. Domestic water systems, for example, don't often get fully coordinated in the design intent process, and they size a pump according to X number of fittings, certain linear feet of pipe, all of those things. Well, if you don't do proper spatial coordination, which is a huge element of BIM, and you start installing that pipe and you put in 32 extra elbows, all of a sudden, your pump is now operating in a different set of its pump, or a different location on its pump curve, hopefully still within that pump curve, because if you exceed the pump curve, guess what? You're taking that pump out, that's probably already been bought, most likely been installed. You're taking that pump out, you're putting it back in. Now you've got a different pump. You have one pump that's no good. You've got all the costs associated with that from a contracting perspective. It can be a big deal. So what we can do as a contractor that understands constructability, we can produce that domestic water system true to form and provide it back to the engineer or design engineer, and they can actually rerun their calculations. If we do it in Revit, they really only have to push a button that will tell them the net set, the suction head, all of those different things that they're concerned about, that's going to allow them to resize that pump, pick a different pump model, which would have energy management, continued operation implications. There's a lot of implications that we can address doing virtual pre-construction. Also gives us the ability to do cost reporting. Lets us compare our estimate versus our actual. We estimate, X number linear feet of pipe at such a size. Turns out that when we do our BIM coordination, due to the building limitations and architectural detailing, that we have to, 15, 20% increase in pipe. If it gets to a point where the cost is too great, we're gonna have to go, potentially have to go to the well for a second drink. But it does give us the ability to do this before construction is even commenced, which is nice. Benefits during construction. Fabrication. That's the primary reason we got into this, was our ability to remove site construction and fabrication of material, right? Threading pipe, grooving pipe, bending metal, all of those things that people end up doing on your construction sites. I'm sure you've seen it on sites. There's potential for oil during the pipe threading process. There's lots of issues. The biggest thing is you move it into a controlled environment. It gives you the ability to control your schedule. You can use equipment that's a little bit more robust. Like, I don't think you've ever seen anyone come into a construction site with a press brake to bend up their sheet metal. You maybe see like a little one, but not a real press brake, or at least I haven't seen it yet. So I'm going to talk a little bit about prefabrication. Here's an example of a 3D and a 2D version right out of one of our projects. I think this is in the office tower of the Nova Center. So it's kind of hard to see in the 2D details, and 2D is a requirement. Our site guys still need them. And there is something to be said about printing a 40-inch piece of paper and being able to look at it. So as much as we like to say 3D is the way forward, and etc., I don't think we're ever going to get away from a guy rolling up a piece of paper and putting it on a desk. It still has its value. This is an example of a coded drawing, the 2D one. Each one of those individual code numbers corresponds to a piece within the building that I can show you on the Navisworks model, take you right to it, give you its full properties, and actually take that specific piece from the model we do, send it right to my plasma cutters in my sheet metal shop, and it will actually cut the shapes so I can make the duct, right? And then here's an example of the actual, so this is one of the pieces for cut 123 on Project Nova Center. It's an elbow. This is the bottom cheek section of that elbow. It's insulated, comes complete with a blank end, has all the dimensions, tells you the size and shape, what the top types of connections are, etc. That all ties back right to a drawing such as this. Right, and you can see in this case, one of the reasons I picked this little tiny section of a building to show you as a duct example is you can see some of the flattening and things that had to occur in order for us to get that duct under there, because we had a very low slab to slab distance, as you are seeing probably especially in the architectural world. What they've done is it's cheaper you get a lot more floors if you can take a foot out of each floor, which they don't typically say, we'll just put 7-foot ceilings in it. They usually take that space away from mechanical. So they drive that ceiling up to give you the beautiful open ceiling look, and now they've squished us down into the 12 inches where we used to have 24. So it actually makes it better for BIM, I guess. So in addition to some of the ductwork, here's an example of our pipe. Pipe, same thing. We prefabricate spools in a shop, send it out. I've got some pictures of those next. Again, we still need 2D. And you can see the colors in the Navisworks model on the right match the 2D drawings on the left because they're produced from the exact same file. Every piece gets labeled with an individual name, its center line. So annotation and detailing for us is a very big deal and a very challenging process because we literally have to label every individual piece of pipe to do this, but it makes such a smooth construction process. It's very much worth it. Here's an example of some prefabricated pipe. This is going into one of the mechanical rooms of the Nova Center. So that is 4 pipe carts. Each one's probably about the length of this table with the pipe on it. Weigh 600 or 700 pounds. They're all on wheels, easily transported them around the site, gives you better site control, does a lot for us. That's only one system of one mechanical room. So you could imagine taking all that pipe in raw, cutting it on site, grooving it on site, trying to figure out with a measuring tape, or at least from an engineer's design intent drawing to put that into place. Whereas we can take that, wheel it onto site, wheel it into the room. The guy can follow, like, it's Mechanics or Lego basically, where they just say, okay, pipe number 7 goes there, pipe number 8's next to it, et cetera, et cetera. They roll through. All the Vic couplings get shipped in a separate batch. Here's some pipe we have in our shop right now for a fire pump set up at Greenwood. The only reason I'm showing you that is because it's 18-inch Schedule 40 pipe. So that means it's 0.5625 inches thick. It weighs about 120 pounds per foot. So trying to manage that on site, groove it on a site, even welding it on a site, any of those things, trying to handle that, it just doesn't become effective to try to do those things in a construction environment when you have the opportunity to use overhead cranes, do it in a controlled environment. So great example of why BIM can drastically impact the functionality and construction schedule of your job. Prefabricated plumbing is one you don't hear a lot about. Obviously, you've probably heard about prefabricated sheet metal, because like I said, they don't take a press brake to the job sites anymore. But prefabricating plumbing, this is actually in one of our Ontario facilities. It was for a hospital. That's why there are so many. Hotels are another great opportunity to do things like this. But yeah, each one of these is on the left-hand side is a toilet with all of the water services, the air hammer arresters, everything built right into it. It's all built on a unistrut frame. We wheel that thing in, drop it down into a hole that's been sited with a robotic station. It all matches up. The drywaller comes in. When we do this, it's the only time you ever hear a drywaller tell a mechanical guy to slow down. Which you don't, that kills at the CANS meetings. Some more addition, this is a gang washroom, so that's actually a male and female combo on the left-hand side. So we would actually roll that in and it would do both washrooms, as you often know, and you can see in most facilities, the men's and women's washrooms are beside each other so they can share a common wall for sanitary purposes, obviously, and reduce the number of riser pipes that you have in your building. We put these on carts, roll them in, drop them down, bolt them up, and we only have to tie in our vent, our supply water, and our drain, and you've got a washroom. It takes around a half a day to install one. Typically, that would be about a week and a half to 2 weeks process on site. Also, from a lead perspective on site, the garbage that's associated with that is drastic. There's all the boxes, all the fittings, the clips, etc. All that gets done in a shop, which gives you a greater lead impact. We get right down to the fixtures. We even put the taps on sinks. And what that does is things like taps and finishing things on a construction site often get scratched, damaged, etc. Doing this doesn't happen. Here's where I'd like to see it go. This is like what, if we could all get together and David said, what are we going to do next? What are we going to, and Jerry, when we talked about this, he said, how are we going to, how are we going to take an action and move forward? I'd like to see a building, and we volunteer to be the mechanical, electrical controls service contractor for that building. I'd like to see total fabrication. What total fabrication is not only am I prefabricating my duct and the electrical guy's doing some prefab on his larger conduit or at least pre-wiring his panels at his shop, fire suppression, refrigeration, all those various sub-trades. I'd like to see it planned right from architectural design, structural design, and engineering design so that we can actually modularize the hallway sections of a building, right, which is what you're seeing here. Even to the point that the drywall is going up, because oftentimes on a construction site, I can't go in and put my duct up because the hallways are so tight because they've taken away all of our mechanical space. I can't get in and put my duct up until the drywall guy puts the first 4 feet of drywall up, because if not, how's he going to screw it, tape it, sand it, paint it, etc. So here we take that whole hallway module, bring it into a shop, all sub-trades put their equipment and supplies onto that module. It gets shifted into the building and it gets hung. You know, it changes the 2D drawings a little bit to more of a total fabrication station, but it changes you literally have to plan it right from structural and architectural, because you have to have the pre-inserts precast in the concrete that actually support those modules. So you saw it being built in the shop, you see it being shipped onto the site, now you're seeing it being hung in the air, right? This is where I would like to see it go. Love to see someone pick a building. Would obviously take a couple years to put the whole thing together, but great opportunity, huge impact on construction. This is an example from the southern US where, I think it's in Texas, where the Texas government states you're not allowed to work on their buildings unless you are a fully BIM-enabled pre-manufacturing contractor. Here's the example of it actually installed on site. I'm gonna run out of time here, so I'm gonna speed up. Benefits during the construction phase, product sequencing. You have a play on that? So in the Nova Center downtown, there's a mechanical room in the P2 basement that has some really large tanks in it, a weird mezzanine. It's where all the chillers, a bunch of the pumps are stored. This video is an example of how we actually sequence the work to go on there straight out of our BIM model. So the pink stuff you saw come in was electrical. That's the main electrical feed and some bus duct for some of the other areas of the building. There was some domestic water in blue, some, I think it's condensate water in green. Then we loaded the upper pipe in the room, which was our chilled and our condensate return, which I think comes in next, is red, and the heating pipe in yellow. After we had those in, the pads went in for the major mechanical systems. We then brought those tanks in because we couldn't you couldn't put the lower pipes in until those tanks were in, obviously. We then put the chillers on top of the pads. We then built a structural mezzanine. Well, actually, I think it was RKO Steel that built the structural mezzanine based on the locations we gave them. They were able to add reinforcement to the mezzanine. Then we put the pumps on top. Then we tied what we'd call the lower set of pipe into the room, which actually connected to the pumps, went back down, connected to the chillers. Chillers then got tied over to the tanks. That sequencing was all pre-planned using BIM. And without it, the room would have taken an extensive amount of time to do. In fact, when we looked at the construction schedule and looked at how we actually performed that work, we beat the construction schedule by about 50%. And you don't really hear that in construction a lot. In fact, if you look at the history of construction in the world, let alone North America, we generally see 1% to 2% improvement per decade in labor productivity. Beating a schedule by 50%. I'm not saying we beat our labor by 50%. We can't sell you a building at half the price. But what we can do is change the speed at which you can construct a building by half. And from an owner's and operator's perspective, that is a drastic impact. If you can be leasing, you know, if it's a 2-year build and you can be leasing it in a year instead of 2 years, that's a pretty big impact. Do you want to play the next one? Oh, and that was just the architecturals coming in after to close the room over. This is the same room done in Navisworks, and it's a little longer video, and if I knew how much I was going to talk for the first 28 minutes and 14 seconds, I would have probably made this a minute long instead of 3 minutes long, but this is the same room shown from an individual's perspective. You can also load a Velociraptor in Navisworks, which is kind of cool. I don't know if my designer, I don't know if that's a stock option in AutoCAD or whether he downloaded it, but the Velociraptor couldn't get up the stairs. So he used the guy, he used the construction guy. There's a girl too, and a skeleton, or the 4 options he had. So this is the same room that you just looked at from a sequencing perspective. And the reason I wanted to show you the video is because this gives you an idea of the size of that room that I was actually talking about. When I showed you the first video, it's like, yeah, some pipes, some tanks, whatever, it all went in. Seems like it was relatively reasonably planned. But then you start to see the size and the scope of it. And then it also gives us the ability from a functional and operation perspective to plan around it. So the valves that you see, the pressure gauges that you just saw, the thermometers that you see during this walkthrough, all of those have to be in a reasonable place. That pressure gauge has to be visible to the guy, especially if I'm prefabricating the pipe in a shop. We need to make sure that when we build the pipe, we cut that threadlet in, that weld to let in, that it actually turns out to be at a reasonable height. If we put it at 7.5 feet, the guy's gonna need a step ladder to check the pressure, or we're gonna need to use a different type of gauge, which requires a different shop drawing, submittal, et cetera, et cetera. Expansion tanks, this is the mezzanine he's walking up. You could see the size of the 4 tanks when he walked by the chillers, how large they were. And then he gets up onto the mezzanine, and you can see the pumps, relatively large pumps. I think they're almost 6 feet in height. pressure gauges, isolation valves, etc. I had to speed up because I only got 30 seconds left. So, additional benefits in the construction phase: material, site cleanliness, site conditions, multi-trade impact, construction schedule we already talked about, change in methods, robotic total placement. You know, there's lots of robots out in the lobby, so using those things based on our design to do things. Material control and as-built. Halifax Central Library, quick anecdote, fully BIM coordinated by us. First job that I've ever been on, although it's only been a decade in the business, but first one most of my trade guys could tell me they've ever seen. We, as the mechanical contractor, placed equipment for electricians. So the plumbers told the electricians where their equipment went with a robot, and it was because there was a linear baffled metal ceiling in the place that was pre-manufactured in the US and had very specific architectural properties that we had to site chilled beams in it, lights, sprinklers, and a few other things. Well, it was actually the plumbing foreman that did all of the siting of the equipment. I'm over my time, but I'm going to take a couple more minutes if I can, David, just to get into the challenges of BIM. So, challenges of BIM, 2D versus 3D. Like we mentioned earlier, this was the part I was saying. We still see diagrams, details, P&ID. Great example in Nova Center, architectural detail in a window, the little window box. I don't know what you guys call that. I'm a pipe guy. The box that the window sits in, on the top of it there's a little light valance. The Revit model didn't show the light valance. The architectural 2D details that they did, because their process was draw 2D, then convert to 3D, as opposed to draw 3D and export 2D, didn't show. The little detail didn't show. So we put a bunch of pipes in there, sprinkler head, bunch of other things. Went to the coordination meeting, architect said, whoa, 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 light valance, great, at least we didn't install it. Right? At least we didn't have our pipes there before they came in and put it in. So some of the other challenges, other trades, technology adoption. Because this isn't a market that BIM is saturated in, other trades, you know, not every contractor is up to our level of understanding of the technology and implementation. Owner understanding, which has been talked a lot about today, I don't think I have to go into that. Software differences. So software differences between the engineers and the designers, the architects, ourselves. The structural guy uses a different software that makes it fabricatable. We use a different software. Our fire suppression group, even within our own company, has to use a different software that does the hydronic calculations, called HydroCAD, for determining the sprinkler system design. Timing. Please, if there's any CMs, owners, designers, construction managers particularly, if we're going to do BIM, give us some time at the front. I already mentioned this once, but it's worth mentioning again, because if we don't have the time to do the model, we can't do it. We're going to just start building it. Other ones, central modeling. I know we talked about the cloud, central modeling. You know, someone mentioned earlier, you click a button and boom, you've got the most updated model. Can't always do that. A lot of groups don't know who owns the model, aren't willing to share. You know, they're worried that we'll get an instantaneous change they made by using the cloud, that we might put a system in, and you know, we're going to come back at them for a change because 2 days later they say, ooh, that was a bad idea, and they move it, and we've already worked. So sometimes there is some benefits to setting milestones. Again, cost of implementation. We still get the odd people who, you know, we're trying to make a project successful through BIM collaboration. And they say, we want $25 a drawing to give you DWGs. It's a $28 million project. You're asking for $25 a drawing. But mind you, there's 650 drawings, or I think someone mentioned a couple of thousand drawings, 5,000 drawings on a job. Well, that's a pretty huge hit. And all we're trying to do is make everything flow along a little better. Trained resources. Chris Davidson, I think, is here. Met at him with the PAC committee. Wanted to increase the ability of the NSCC graduates to have more BIM. Kirby, same thing. I think we talked to PAC about the same thing. We need more trained resources, right from the tradespeople to our young software, or gamers actually is a good. We use a lot of gamers, and model ownership. Journeyman's an interesting one. I'm going to button this up real quick. When we first started this process 6 or 7 years ago, Tom got up, said, this is the way of the future. We're going to do everything this way. A bunch of the trade contractors stood up, or tradesmen stood up and said, you're crazy, we'll never do this. I know what I'm doing. Engineers are cutting the blood flow off your brain and all this other stuff. That all went down. The exact same guy just told me, we gave him a section of a building that had some underfloor, raised floor with some underfloor mechanical systems, and he actually came into the design department and said, I can't do this, would you guys do this for me? I almost wanted to record it and send it to Tom as a thank you for putting the last 5 years of work in, but anyways, I digress. That's it. Sorry for being 5 minutes late. My bad.
Great. Thank you very much. Much appreciated. Somebody actually talks faster than I do. I can't imagine we've got any questions because that was a wealth of information in just 40 minutes. Thank you very much. A couple of points come to mind for me. That level of sophistication, that's based on, commitment, experience, and so on and so forth, right here in Atlantic Canada, so I think that's just absolutely fabulous. Many of you already knew that. For those who weren't aware of the competencies and capabilities of Atlantica Mechanical, I'm sure that was a real eye-opener. So, kudos to that organization, to Tom, for making that investment and being a leader, setting what I would call a high watermark that, many of us, regardless of whatever discipline we're in, can really look at that and say, hey, they looked at it as an investment, not a cost. Yes, it is a cost, but it's an investment in the future. So.